The next property in which we will learn about the identity of 0 says, the name of the property is additive identity of 0, right? So in this property says that whatever rational number is added to 0, the sum is always the same rational number. That means if suppose you have a upon b as your rational number and 0 is added to this rational number, the sum of the two will be a upon b only. Even if we have minus a upon b added to 0, then also the sum of the two is minus a upon b. It is quite similar to the concept of whole numbers and integers, where if suppose 3 plus 0 are added, the sum remains 3. If minus 3 plus 0 are added, the sum is minus 3. That means the number itself. So when we talk of the additive identity of 0 on rational numbers addition, then also it remains the same. Whenever any rational number is added to 0, then the sum is the number itself. Let's see how with the examples. Okay. Example of additive identity of 0. Okay. Now let's take randomly any rational number. Minus 2 upon 3 plus 0 will give you minus 2 upon 3. Take 1 upon 6 plus 0 will give you 1 upon 6. Okay, let's take minus 7 upon 20 plus 0 will again give you minus 7 upon 20. Let's take one more, minus 5 upon 16 plus 0 gives you minus 5 upon 16. So this is how in all the cases, whenever to any rational number 0 is added, the sum remains the number itself. Now let's talk about the last property of addition on rational numbers. This property talks about the existence of additive inverse of a rational number. Now what is first of all an additive inverse? Let's recall the concept from the integers, right? If suppose I have minus 3, if I have to write its additive inverse, what will be the additive inverse? I will change the sign and it will be plus 3. And when these two will be solved, what will be my result? 0. Okay. So this is the concept of integers, where we have already learnt that what is the additive inverse of any integer. The additive inverse is the number with the opposite sign which is present in the given number. Okay. So here 3 had a minus sign, so its additive inverse becomes the positive 3. So similarly, we have the additive inverse property with rational numbers also. So the property is existence of additive inverse of rational numbers. Okay. So let's say if suppose I have a rational number a upon b. So what is its additive inverse? Certainly minus a upon b. So when you add these two numbers, then the condition comes a upon b minus a upon b, which gives you 0. Is it clear? So this is the last property of existence of additive inverse of rational numbers. Now let's learn the same with some of the examples. Examples of additive inverse of rational numbers. Okay, now minus 2 upon 5. The additive inverse is plus 2 upon 5. That is minus 2 upon 5 plus 2 upon 5. 5 becomes the common denominator. Then minus 2 plus 2 gives you 0 upon 5, and this gives you 0. This is how the additive inverse property of rational number works. Let's take another example. Minus 7 upon 10, or let's take positive 7 upon 10. The additive inverse is minus 7 upon 10. When the two of them are added, first of all the sign is changed, 7 upon 10 minus 7 upon 10. Taking the common LCM 10 or the common denominator 10, 7 minus 7 gives you 0 upon 10, which certainly results into 0. So this is the property of additive inverse of rational numbers on additions. Now let's quickly take a glance on what all things we have discussed in today's session. First of all, we have spoken about the closure property, where the sum of any of the two given rational numbers is always a rational number. Then we studied about the commutative property. Then we learnt about the associative property. Then additive identity of 0. And last, additive inverse of a rational number. So these were the topics which we have discussed in today's session. Let's come to the next topic now. Good morning. Welcome to the next session on rational numbers. Today we will be talking about the properties of rational numbers on addition. So whenever we perform the operation of addition, which all properties we need to look after so that the operation can be successful. Okay, so let's begin with properties of addition on rational numbers. Basically, these properties are same as of the properties which you have studied on integers. So you all have already studied all the properties of addition on integers. So for the rational numbers also, we have similar kind of properties. To begin with, the first property that is we are going to talk about is closure property. According to this property, when there are two rational numbers whose sum is to be found out, then we are supposed to get as their sum the rational number only. That means whenever you add two rational numbers, their sum is going to be a rational number only. So, according to this property, if A upon B and C upon D are two rational numbers, to be added, then their sum will always be a rational number. Okay, so this is what the property of addition on rational numbers says, which is the first one, the closure property. The closure property says whenever you are going to add any two rational numbers, their sum will always be a rational number. Similarly, you all have studied about the closure property of integers. The closure property of integer also says whenever two integers are added, the sum is always an integer. Similarly, when any two rational numbers will be added, their sum will definitely be a rational number only. Let's understand this with an example. So we begin with the example of closure property. Let me take two rational numbers, minus 5 upon 16 and 7 upon 12. I am going to add these two rational numbers, 5 upon 16 plus 7 upon 12. So first step, as we have discussed in the previous sessions, is to take the LCM. So the LCM of the two numbers is 48. What is the LCM of the two numbers? 16 and 12, that is 48. Now, when I divide this 48 by 16, it goes 3 times. How many times? 3 times. So when minus 5 is multiplied by 3, in the next case, when I divide 48 by 12, it goes 4 times. So 7 into 4. Then next step is minus 5 into 3, that is minus 15, plus 7 into 4 is 28 upon 48. So when are we going to subtract 20 from 28, 15, what are we going to get? 8 minus 5 is 3 and 2 minus 1 is 13. Because 28 has positive sign and 28's numerical value is greater than minus 15. So obviously the sum of the two will get a positive sign. So 13 upon 48. So this 13 upon 48 is also a rational number. What we have done, we took two rational numbers here, minus 5 upon 16 and 7 upon 12. When I added these two, first of all, I was supposed to take out the LCM. I took the LCM here as 48. After calculating the LCM, I was supposed to find the equivalent rational numbers of these two, which I have done here. I got minus 15 here for minus 5 upon 16 and 28 for 7 upon 12. When I solved these or performed the addition on these two numbers, one has a negative sign and the other has a positive sign. So when the signs are different of the integers, we have learnt that we are supposed to do the subtraction. So on subtracting 15 from 28, my result was 13. So 13 upon 48 is the sum of the two given rational numbers. Now let's come to the next property. That is the commutative property. Commutative property. This property basically talks of the arrangement of the numbers, that is the rational numbers arrangement when we are doing the addition. Let's take very simple example with some other numbers first. Suppose I take 5 and I add 3 to it. What is my result? The sum comes to be 8, right? Now if I interchange their positions, I shift 3 here and 5 there, then it becomes 3 plus 5. After adding them, again, the sum comes to be 8. That means on the arrangement or rearrangement of the two numbers, there is no difference in the sum. The sum comes to be the same. The sum which we are getting is same, right? So this is what the commutative property talks about. The commutative property of the rational number says whenever two rational numbers are added, it doesn't make any difference to the sum if we interchange their places. If suppose you have kept first rational number at the first position and then the other one, then there will be no difference in the sum. Okay, now if two rational numbers are added, say A upon B and C upon D, then after their rearrangement, the sum remains the same. So how does it happen? It happens if suppose A upon B plus C upon D, I will get E upon F, right? Now if suppose I shift their places, that means this entire rational number gets shifted to this side and this gets shifted to that side. C upon D plus A upon B will also give you E upon F. Is it clear? This is the commutative property of addition on rational numbers. Now let's understand this with an example. So when we talk of this commutative property, we'll take two numbers, or I should say two rational numbers. Example of commutative property. Okay. Now I will take two numbers, minus 2 upon 3 plus 1 upon 6. Okay, these are my two numbers, right? After this, what I will do? I will take the LCM. On taking the LCM, what do I get? See, which property can you all identify that we have learnt about the conditions of addition? So, which of the two is applied here? The multiple one, right? Here 3 is the number and 6 is its multiple. So that way we can find the LCM. By finding the LCM also this can be solved, or by applying that condition of multiple and its number and its multiple, that also can be applied here. Now after taking 6, This 6 is when divided by 3, I get 2. So minus 2 multiplied by 2 plus 6 remains 6, 1 multiplied by 1. Why this 6 remains 6 only? Because 6 divided by 6 is equal to 1. Clear? Minus 2 into 2, minus 4 plus 1 upon 6. So what is my answer? Minus 3 upon 6. That is minus 1 upon 2. Clear? What I have done here? I have reduced the rational number to its simplest form. That is why the sum has come minus 1 upon 2. Now, let's take it other way round. That means, now let's understand the commutative property with the other arrangement of the rational numbers. Now, I will keep 1 upon 6 first and then I will keep minus 2 upon 3. Now, in the previous solution, what we did, we directly found out the LCM. But here, there is one more step involved. That is to remove this bracket. How are we going to remove this bracket? 1 upon 6 comes as it is. Then after this, the multiplication of the two signs, that is plus sign and minus sign, takes place. So what do I get here? Minus 2 upon 3. Clear? Now, you do not have to get confused with this negative sign, that we are talking of the properties of addition of rational numbers. How come negative sign has come here? As I have just now explained to you that there is a minus sign inside the bracket and a positive sign outside the bracket. So when we solve or when we multiply these two signs, I get negative sign here. Is it clear? So this is how this negative sign has come over here. So do not get confused that because in the rational numbers we talk of the integers, and whenever there is a solution of integer, we might get different signs as we are getting in this case. So let's solve it now. I will take the LCM. LCM comes to be 6. Clear? Then 1 multiplied by 1 and here minus 2 into 2. So 1 minus 4 upon 6, which gives minus 3 upon 6. Now this will also be further reduced, right? On reducing minus 3 upon 6, I again get minus 1 upon 2. Now this minus 1 upon 2 is similar as that of the previous sum. Okay, so that means it is proven that the commutative property of addition on rational numbers do exist. Now let's come to the next property. The next property that we will talk of is the associative property. In associative property, again we will be talking of the arrangement of the rational numbers, but there will be arrangement plus grouping of the rational numbers taking place. When we say that we have to solve or we have to add any 3 rational numbers, then how are we supposed to do that? Let's see. In this, I will have, again, before coming to the rational numbers, let's understand this with another example of maybe whole numbers or natural numbers. 5 plus 3 plus 4. Clear? Now I made the arrangement like this. I have placed 5 and 3 in the bracket or inside the bracket, and 4 I have kept outside. Is it clear? Now I have to find out whether this sum is equal to the other arrangement where I will be keeping 3 and 4 inside the bracket. So I have to find out whether these two arrangements are going to give me the same sum or not. Fine. 5 plus 3 is 8. First I will solve the bracket. Plus 4, it comes to be 12. Here 5 plus will remain same. 3 plus 4, 7. Then again this comes to be 12. So when we talk of natural numbers and whole numbers, the commutative property exists with them. Now let's see the same if takes place with the rational numbers or not. Now I have three rational numbers. Okay, A upon B plus C upon D plus E upon F, right? Now I will put them in a bracket. Then I have to find out whether they are equal or not. In the next case, I have arranged C upon D plus E upon F inside the bracket. Now, this is what the associative property says. This says that in both the cases, the result will be same. So let's understand by taking an example. 3 upon 4 minus 2 upon 5 and 7 upon 10. Okay, these will be my three rational numbers. So let's understand with the example. Example of associative law, or you can say property. Both the words are correct. So I have taken 3 upon 4, then I have taken minus 7 upon 10, and then I have taken minus 2 upon 5. Okay, now using these three rational numbers, we are going to apply the associative property. 3 upon 4 plus minus 7 upon 10 plus minus 2 upon 5. Okay, so first step is to remove the positive sign. 3 upon 4 minus 7 upon 10 minus 2 upon 5. Clear? After this, I will take the LCM. Now, what is going to be the LCM of these two numbers or these three numbers? Will it be 20? Yes, it will be 20. When I divide 20 by 4, I get 5. So 3 into 5 minus. When I divide 20 by 10, I get 2. So minus 7 into 2. When I divide 20 by 5, I get 4. So minus 2 into 4. These are the equivalent numerators of the given rational numbers. Now after that, 15 minus 14 minus 8 upon 20. Now what I am supposed to do, I will add the negative ones first. So 15 minus 8 and 4, 12, 1 carry 22 upon 20. Clear? After this, I am writing here. Now I have to subtract from 20 to 15. 12 minus 5 is 7, right? And 1 minus 1 is 0. So what do I get? Minus 7 upon 20 as my result. Is it clear? Now we will write the observation or the result here, and we will see whether if rearrangement of brackets is done, then what will happen. Okay, now 3 upon 4 plus minus 7 upon 10 plus minus 2 upon 5. Okay, so this is what we are going to do. Now, the association is between 3 upon 4 and minus 7 upon 10, and minus 2 upon 5 has been left alone. Now, let's solve. We will solve the bracket. 3 upon 4 minus 7 upon 10 plus minus 2 upon 5. Again, the LCM will come 20. 3 into 5 minus 7 into 2. Clear? This minus 2 upon 5 will remain outside. So 15 minus 14 upon 20 plus minus 2 upon 5. Okay. Now it becomes 1 upon 20 plus minus 2 upon 5. Clear? Now we are going to solve. The last step, that is 1 upon 20 plus minus 2 upon 5. Okay. Bracket we have already solved. Now we are going to solve this. Now again my LCM will be 20. Plus into minus will become minus. So it will be 1 as it is. And here when I divide 20, minus 2 into 4. That is 1 minus 8 upon 20, and it results in minus 7 upon 20. So can you see, we have written the sum of the previous arrangement of the numbers, that was minus 7 upon 20, and here also after the other arrangement we have got minus 7 upon 20. So it says the associative property of rational number on addition says that there is no difference if you arrange the rational numbers in different orders or in different associations or in different groups, the sum remains the same. Now, after this, we will talk of the additive property of 0 on rational numbers.